Day 2 of completing the square is going to have problems with a leading coefficient. Now, first thing we should notice about this problem is that there's a coefficient in front of this x squared. We have a 3 here. We didn't have that yesterday. Okay, we want to check to see, can we just divide all these numbers by a 3? If we can, it makes the problem a lot simpler. But unfortunately, 17 is not divisible by 3. So we have to do this one the long way. All right, let's take this 17, let's move it to the other side. Minus 17. All right, so now we're here. We're going to complete the square like yesterday, but before we can do that, we want to make it look like the problems from yesterday. Namely, we want to get a 1 in front of that x squared. So to do that, we're going to factor out a 3. Okay, and at this point, we have two numbers that are divisible by 3. So let's take this 3, let's move it outside the parentheses by factoring it out. Okay, and it turns into this. So if we were to take this and distribute it back in, it turns into this up here. Okay, so we're just reversing that. All right, and this problem inside the parentheses looks like what we did yesterday. So now we can take this 4, we can cut it in half, we get a 2. 2 squared is 4. That's going on that parentheses there. Now, we're not putting that on the other side because on the other side, we want to keep the equation balanced. And we didn't just add 4 to the left side, we're actually adding 3 times 4. Okay, so we really have 3 times that 2 squared or 4. So we're really adding 12 to this side. So we have to add 12 over here. Okay, and now at this point, we can write the actual equation that we're going to solve. This is our perfect square trinomial. Just like yesterday, we can write it as x plus 2 squared. And then over here, we can simplify it to negative 5. Okay, now we want to solve this. First step, divide by the 3. Now we can square root them because that parentheses is by itself. And anytime we get rid of a squared with a square root, we need to put the plus minus in front of this radical. Okay, we have a fraction inside a radical. We're going to need to rationalize it by multiplying top and bottom by that radical that's on the bottom there. We also have a negative inside here. We're going to have to pull that out as an I. Okay, so this bottom 2 3's, it's going to move outside, just turns into a 3 with no radical sign. Here, nothing matches up on the top. Radical 15, and the I is out front. Okay, so it looks like this. And then we have our last step, just move this 2 to the other side. So x equals negative 2 plus minus I radical 15 over 3. Let's do another one. 2x squared minus 4x minus 14. When you look at this, we should see that all these numbers are divisible by 2. Okay, so what we can do is let's divide the left side by 2 and the right side by 2. Now, when you guys see this, a lot of times you want to write no solution. It's not. 0 divided by 2 is 0. Okay, the left side, all these numbers just get cut in half, and this turns into a problem like we did from yesterday. Okay, now we're going to take the 7, move it over here, complete the square. Okay, it's the same thing on both sides in this one, so we just put a 1 in both. Okay, x minus 1 squared equals 8. Square root, break down this radical here. Okay, that'll be a 2. So it's 2 radical 2, and then move that 1 over. One practical method of completing the square is switching from standard form of an equation to vertex form. So we want to switch this ax squared plus bx plus c into vertex form where we have a parentheses squared plus or minus a number. First step here is to take this, these first 2 terms, okay, and just separate it out from that plus 17. Okay, so it's these 2 terms that we're going to be completing the square with. All right, so I group those together, x squared minus 8x plus something, that completes the square, and then that plus 17 is at the end there. Now we complete the square just like normal, divide by 2, we get negative 4, square it, it's a 16. Okay, add that 16 to both sides. Okay, this whole thing turns into the first part of our vertex form. It's an x minus 4 since it was a negative squared. We have the plus 17. In vertex form, we don't want it to be y plus 16 equals. We just want it to be y equals. So the last step is to take this 16 and move it over here. Okay, so we do that. 17 minus 16 equals 1. That's our vertex form. At this point, a logical question would be, what's the vertex of this parabola? And remember, it's the opposite, same. So the vertex would be 4, 1. If we have a coefficient on that x squared, same idea as we did in those first two problems. So we're going to separate out that plus 9 at the end by lumping together the 2x squared plus 12x, and those are both divisible by 2. So we're going to take a 2 out and move it in front of the parentheses. So we have the 2 out front. Okay, x squared plus 6x was left over, plus something to complete the square. That plus 9 is at the end. Cut this guy in half. We get a 3. Squared equals 9. Now, just keep in mind that we didn't add 9 to the right side. We actually are adding 18 because it's 2 times 9 there. So over here we have to add 18. Okay, this whole parenthesis here is going to turn into x plus 3 squared. Oops. All right, so 2x plus 3 squared plus 9. Okay, on the left side, we don't want y plus 18. We want just y equals. So move that 18 back to the right. Okay, y equals 2 parentheses x plus 3 squared minus 9. Opposite, same for the vertex. So the vertex would be -3, -9.